Hi, fourth graders. This is our science e-learning lesson for Tuesday, March 31st. So today you're going to be reading pages 324 and 325, and it's about volume, the volume of solids versus the volume of liquids and other objects. So what I'd like to do is just do a little preview of what it is that you're going to be reading about. So we talk about volume. Now, I want to take us back a minute to when we were talking about area. And for area, if we wanted to find the area of this container, in a sense, what we would be doing is looking at the flat surface of this container, and we would be measuring the length and the width. And remember that the formula we used for area was length times width. Now, when we were in the classroom and we talked about the area of the classroom, we looked at the floor because we had 1 foot square, the square 1 foot tiles on the floor, and we said that in area it was square units, and so we looked at the number of square 1 foot tiles that we had on the floor, and by doing that we could count up and we could figure out the area, or we could measure the length of the classroom by the width of the classroom, and when you multiply the two, that gives you the area. So if we wanted to do the area of this container, we can do the same thing, measuring the length by the width, and that would give us the area, the number of square units that it would take to cover the surface of this container. But when we're talking about volume, volume adds a third part to that. Not only is it length and width, but it's also the height. So when we take a look at the container, now because we're adding height to it, we're no longer looking at something that is flat. So we don't use square units with volume, we use cubic units coming from a cube. You know what a cube is, a block, a die, that's a cube. So if we have this container, in a sense then what we would be doing is taking our cubic units or our cubes and stacking them up inside the container, looking to see how many of these cubes it would take to fill the container. Now, I'm not going to take the time to do all of that here, but I just want you to get an idea of what that would mean. Looking at the number of cubes that it would take to fill up the container. So it's not along the surface, it's not flat anymore. Volume now adds that height to it. So the formula for figuring out volume of solids is length times width times the height. Okay, there are three parts to this now. It's length times width times height. Now the example that you're given in the middle of page 324 is that if a box measures 5 centimeters long by 2 centimeters wide by 8 centimeters high, you would multiply that together. 5 times 2 is 10, 10 times 8 is 80, and that would be 80 centimeters. Now, as I said, when doing volume, you're talking about number of cubes or cubic units that it takes. So you have to identify that here as well. Remember when we did area that you always had to make sure that you labeled it as square units. Well, here you're doing cubic units. So you could either say 80 centimeters cubed by using the little 3, the exponent 3, or you could say 80 cubic centimeters. Either way, it's correct, but you do need to identify that you are now using cubic units. Now, going back to the classroom for a minute, if we wanted to figure out the volume of the classroom, then what we could do is we could take boxes, our cubes, start in one corner, and begin to stack those boxes up from floor to ceiling. And we would do that, and we would keep going along until we had them all in front of the windows. And then we would have to do another row in front of that, another row in front of that, and we would keep working our way right out of the classroom until the classroom was completely filled with those boxes stacked from floor to ceiling. So again, it would be we could figure out the volume of the classroom simply by using this formula where we could measure the length by the width times the height. Okay, now that's volume of a solid. Now for liquids, liquids don't have a definite shape, so in order to measure a liquid, we can just simply put it into a graduated cylinder, which in this case I'm using a measuring cup. I don't have a graduated cylinder here, but I do have a measuring cup, and this is of course another way to figure out the volume of our liquid. So right now this is at 200 milliliters. Okay, so I have 200 milliliters of water. It just has some blue food coloring in, make it a little bit easier to see. But this is just the water, and again, the level is 200 milliliters. Now, the reason I'm showing you this is because if you have an object that's an odd shape and you wanted to figure out the volume of that object, you could then put it into a graduated cylinder, or in this case a measuring cup, and you can look at the difference in the measurement of the water. So before I was at 200 milliliters, now the water level has risen to 250 milliliters. So it was at 200 and then it rose to 250 milliliters. And so what you would need to do then would be to subtract that difference. So the 250 minus the 200 shows 50 milliliters. So that if you look at the picture on page 325 where you see the two graduated cylinders, okay, it also lets you know then the volume of the object that then was placed into the water, in this case would be 50 milliliters. It just so happens if you take a look at the graduated cylinders here, okay, they showed you a ball being placed in, and it said that the water level rose from 50 to 55 milliliters, showing that that ball then measured 5 milliliters or 5 centimeters cubed. Okay. 50 milliliters or 50 centimeters cubed. Okay, so today I need you to read both of these pages again, and it will help you better understand and review the things that I just demonstrated to you. And then you're going to answer questions numbers 1 and 2. Again, if you have questions or you need an explanation on something, please make sure that you reach out to me. I'm here to help you. Okay, I'll talk to you later. Bye.